So just the main points of what we talked about last week, all the little Python that we did. We talked about comments. So any text after a hashtag in a code line will be kind of ignored by Python. So you can use that to take notes. The main thing we talked about was data objects. This is kind of the nouns of coding. And these hold the data. So we had the string type data object, which is just like any text. It could be anything really. Text digits, punctuation, anything like that. We talked about kind of quantitative type data, and we have two, but they can be used interchangeably. Int and float. Int is just whole amounts, so -1, 0, 1. Float is a floating point or a decimal point. So it'd be something like -1.0, 0, 1.2, 3.999. So that's just decimals. And then we also talked about a Boolean type data. And that's just a data object that can only have two possible values, true and false. And we use those a lot down this way when we did things like if and else clauses. We want to check some condition to see what set of instructions we would do or maybe not do depending on some condition. To make most of these data objects, you just take a value. If it's a string, you put it in quotes. If it's int or float, you can just put it as is. And if it's a bool type data, you can do true, false, capitalized. Then you just use the assignment, which is the equal sign, and then you can choose any name that you want to give it. And that's how we make most all data objects in Python. We also talked about, since we have so many data types, how can we use them? When can we use what breaks if we try to do what? And that's when we talked about types and casting, changing between types. And we have a couple functions that take an input, and that input goes inside the parentheses. And then it gives back that object as a new type. So if we put in, 10 into the float function, it would give back 10.0 like that. Each type has specific things we can do with it. Last time we talked a lot about ints and floats, so there's a lot of math type stuff. So with ints and floats, you can use all the basic math symbols, things like that. We'll see next class and the last class what we can do with strings, text data. We can chop them up. We can look inside to find specific phrases inside of a text, things like that. We can do things with bools and that kind of stuff too. So each type has its own things that it can be done with it. Some types can be changed into a second type, and then some types are kind of non-compatible with different types. So if we try to stick in the string hello to the int function, that can't become an int, so we would get a bug message in Python. Once we got those basics out of the way, the stuff of Python, the nouns, we talked a little bit about comparisons with these, the usual symbols, less than, greater than. Is equal to is a double equal sign, and the not equal to is exclamation point equals. And when we take two values with some comparison between them, it's going to result in a true false result. And then we talked about how we can use that true false from that condition that we make and combine it with things like if, elif, and else. And that basically lets us choose when and how to follow some set of instructions. If some condition, then do this, but maybe if not, we do something else. So that's how we can kind of not always do the same thing every time we code. We can have code dependent on the data like that. At the end of last class, we just talked about a couple kind of convenience tools. We talked about how you can use the and key phrase to kind of combine two conditions. So in this if clause, we have two conditions. And since we link them with an and, that means they both have to be true to go inside that if clause and execute the code in that indent. If one of these was false, the whole thing would be false, and we would just skip that if clause and go on to the next code beneath it. The most basic function in Python we've been using a lot, and that's just the print function. We can just stick some value, some data object inside. We can stick multiple inside and just divide them up by colons. We can see in this, I just have kind of like a plain string value by itself. It's not in an object because I just have the value like that. And then I have some object in it as well. We don't know what name equals, but name equals something. And then it'll print out this statement to the console. So print is pretty easy to use. And we'll be using a couple additional functions today. So I just want to mention again, print is pretty unique as a function in that while it accepts values, those things that we stick inside the parentheses, it takes those values and does something to them. It prints something to the console. But what it doesn't do, which most functions does, is it doesn't give us back anything in code. So most functions we use, you give it some input. You might have a function, and we'll be making custom functions. We'll be writing them ourselves. We might have a function called average, and it might take as its input a list of student grades from some quiz, and then its output would be maybe a float that is the average of all those kids' tests. So when we have most functions, we can kind of do something like this. And again, we can read it right to left. We say take the function, in this case int, take its input. That function is going to result in some output. In this case, it would be the int1, changing the string 1 to an int1. And then we immediately assign it to a new data object. So that's what I mean when functions usually give us something back, and then we can save that output as new data, as a new data object. But print kind of just takes something, puts something up on the console, and it doesn't really give you back data like that. So that's most of what we did in the last class, a lot of the basic tools. And we just want to keep in mind as we kind of build up some new tools, that basically Python, as well as any coding language, is basically just a set of logical instructions to kind of check conditions and do stuff to data. Again, mostly dependent on like if X, then Y, when do we want to do things? How many times do we want to do things? But in essence, we can think of it just kind of like human beings. It's kind of like just making a set of instructions. And then to make it into code, we just need to know the kind of syntax of, in this case, the Python language. So when we do these practice problems, a good thing to do is kind of take a step back and not think in Python, but just think, how would I logically do this if I kind of had to do things one by one and I really had to lay out all the steps explicitly, and then we can get to the Python, all the new Python code, the punctuation, the indenting, things like that. So think about the instructions and then we can do it in Python. That's a good tip to people new to coding languages. Okay. So this is the stuff we didn't quite get to last time. And it's one of the last big tools in the basic toolkit of not just Python, but any programming language. And say we had some situation, as an example, we might want to run a Python program that counts down from 10 to 0. And we might just use the print function to display that. How would we do that as of now with what we have now? Well, the issue is, while we know how to do any single step, we can print 10, print 9, things like that. We can do logical comparisons, we can do math operations, depending on what we want to do. But we can only really do a single step at a time. How can we do a lot of steps at once? And how can we do a lot of steps with a little bit of code? So right now, all we would know how to do is, maybe something like this. we right now only really know how to do a single step at a time. We don't really know how to kind of consolidate code and use it again and again. Because obviously, if we want to count down from 10 to 0, intuition probably tells us that we don't really need to spell out and write each line of code. That would be, way too much to do. So how can we use the same bit of code, use it again and again with some slight changes? Because we can see in this example, I'm using the same thing, basically each line. I'm using the print statement, and its input is some amount, 1098. And we just see a small change. This is 10, this is 9, this is 8. So if we know that Python is just some set of logical instructions, if I was telling someone how to count down from 10 to 0, I might not put out 10 steps on a sheet. I might just say, like begin at 10 and count down. And each time you count down again, -1 from the last result. So count down 10, -1, count down 9, -8, count down 7. So by kind of using some logic, we can kind of abbreviate all the steps into just a few steps to kind of loop like this. So again, if right now, if we wanted to calculate the sum of the all the numbers between 1 and 20, right now, all we really know how to do is something like this. We would just have to kind of add it all up manually, but obviously that's not the case of how we would actually do it. If we had to count up the sum of all the numbers up to like 1,000,000, that would be impossible counting it up this way. And that leads us to one of the last big tools that we have, and one of the biggest tools in all of programming, and that is the idea of the loop. So a loop is when we execute kind of set commands a specific amount of times. So loops let us use the same code and again and again and again without writing it again and again. We can just write it once maybe, but we also want to change a few things each time we repeat that code. So if we want to count down 10 to 0, well, we do the same thing each time. We print something out, but we just change what we print out each time. We go 10, 9, 8. So we can maybe say that in 2 lines, say something out loud in 1 less than what we said last time, instead of the full 10 lines. So let's see an actual example of this so it kind of can begin to make sense in Python. So we have 2 types of loop in Python. This is the 2. We'll be looking at a while loop to begin with. And a while loop is a special type of loop that basically runs an unset amount of times until it reaches some condition. So essentially, we can see in this line, while something, and this is just like an if statement, while condition is true, keep running this code again and again and again until this condition is false, and then we go on to the next code. Just like an if block, when we say if x is less than 10, then you do that block of code inside the if clause. But if not, we skip on down to the next thing beyond the if code block. So let's take a look at a quick example of this. So let's say we want to kind of like the counting down from 10 idea. So let's say we want to make a little program that has us jogging. We want to keep track of how many miles we do. And we want to jog maybe 7 miles or something like that. So what we might do is we might say, we'll call this miles. We'll make a little data object and just keep track of how many miles that we run. So say I don't have any miles yet because I'm going to do it in my loop. And I'm going to say, while something is true, let's keep doing these steps. What do I want to be true? How long do I want to keep doing this? Well, while miles is less than, we'll say 5 to make it not so long. So while miles is less than 5, keep doing what's inside this indent. And it indents automatically just like the if block. And now we can say, we can put a little print statement inside, and we can say run 1 mile. This will happen every single time we run the loop. And what we need to do is increment miles. So we'll do that real quick, and then I'll slow down and explain what we've done. And let me go ahead and run this. Okay, so let's take a look at what we've done, and we'll look at it top to bottom. So for the top, we have a data object, some amount of miles, and we begin it at 0. And then we say, while miles is less than 5, keep running what's indented inside the while loop, top to bottom, again and again. So I print run 1 mile. Then I increment miles by 1, so it's going to become 0 to 1. And then when I get to the bottom of this, I come back up to the top line of the loop again. So that's why we see this so many times. So now I print run 1 mile again. Then I come back down to this line. It's going to jump up to 2. And same thing until we get to 5. And we can even modify this. Do something like this. So we can see how the data is changing. And so we can see we begin at 0. And we can see maybe we'll move this down below it. Let's see what that does. Okay, so now it prints out run 1 mile and 1 instead of beginning at 0. So we had to just switch those 2 lines. But we can see it's running this one, doing this one, and it keeps going until we get to this point. And then at this point, at some point, 5 goes up to 6. Then when I come back up, each time I run the loop, I'm just checking my clause again to see if it's still true, my condition. And then at some point, miles is going to be equal to 6. 6 is not less than 5. So then we come back down to this point. Just like that. And we can even check that. So this is the basic idea of the loop. And we'll see a lot of examples of what we can do with the while loop and that second type of loop that we'll be doing today too. But essentially, we can see what we have is an ability to do the same thing again and again. So we have this line that we basically want to do again and again. If we didn't have a loop, we'd have to write this out 5 times. And we have the ability to modify objects inside each loop so that when we get to the next iteration of the loop, that object is slightly changed, but we can run the same line again and again like that. If we take a look, I'm going to copy and paste this so I can show you what's going on. This is a site called, it doesn't say, pythontutor.com. And you can run Python code in it. And what's useful about it is it goes step by step, and it's going to show us how things update and things like this. So I'm going to run this code, but it's only going to go 1 line at a time. So we can see Python reads top to bottom. So we initiate the code, and it begins with just saving miles as a object, and this is its value in the beginning. Then the second step Python is going to do is just check this clause. It's going to pass that because 0 is less than 5. I'm going to increment miles by 1. So now miles is equal to 1. Then I'm going to print this line like that. And then when I get to the bottom of the indented code block, I come back up to my condition and check it again. So I can see 1 is still less than 5. So I pass that test and come back inside and just do it again. Increment miles from 1 to 2. And then I print the statement again. But because this is dynamic, it's using an object. I just didn't write some text. I can have the same static text with an updated object in it. So now I get 1 to 2. Keep doing the same thing, 2 to 3, print it out. Keep checking my while loop, and this will just keep going as long as I want. And then we can see at this point, miles is equal to 5. My 5 is not less than 5. So I'm going to skip all my while loop because I'm done with it, and then come back down to the next bit of outdented code like this. If I had changed this to like miles less than or equal to 5, I might do that one last time. But because 5 is not less than 5, I have finished my code like this. And you can see finally I get to that done statement once I loop this as many times as I need to. Until 5 is not less than 5, so while false. So begin to go to the next lines of code. So that's basically what all loops do. It's going to be the same with the second type of loop we do. So we just have to keep in mind, we go top to bottom, come back up to the top, top to bottom. And then when we finally finish, we come outside to any subsequent code that we have like this. This is a good tool to use as we begin to build kind of complicated Python code, and we have a lot of objects to juggle and things changing. This might be a place you come to copy and paste your code into to really see what's happening at each step, because it's easy to make little mistakes and things don't come out as intended. So you want to see what's happening to these objects, what do we do at each step, things like that. Okay. So now that we can do things again and again, loops being one of the biggest tools in any programming language, we kind of had to add not a Python tool, but like a planning tool to what we do when we code. And something that a lot of people do, students, professionals, is the idea of, it's called pseudocode, but it's basically just a plan of the code that you want to write. So it's kind of a blueprint of Python code that we want to make. And it's kind of a mix of plain English and kind of Python shape. And we kind of use comments to lay it out. It's a map of the plan that you want to do. And it's helpful to, again, like we said at the beginning of the class, think about like the human language instructions that we want to do in the beginning, and then kind of swap those in with actual Python code. So let's do a problem. We'll begin with doing a blueprint of pseudocode, and then we'll swap in actual code to do it. So let's go back to that problem we had at the beginning of the class when we didn't have the loop yet. We want to add up all the numbers between 0 and something we'll call n. It could be 20, it could be 100, it could be 1,000,000. We just want to see what would happen if we add up 1 plus 2 plus 3, ... all the way to that n. So we'll begin with this idea of pseudocode. And it's basically the steps of how we'll do it. So this is what it might look like. So we'll do something, and it's all going to be in comments to begin with. So we'll say, if we want to do something, add up between 0 and some n, that sounds like a job that a loop might do. So let's say, we'll just put, while loop run until counter is equal to n. So I'm going to basically be counting up from 1, 2, 3, all the way up to n. So I'm going to be counting something. So this is going to be my condition of the while loop. And then I might say inside, add counter to total. So I'm going to be, total is equal to 1 plus 2 plus 3, like that. And then we might do something like increment my count. Because if I begin my count at 1, I add it to total. Well, then I need to change it to 2. So on the next loop, I add 2 to my total. So I have to add it to total, and I have to increment it so that in the next round, I can be continuing to go up. So this is kind of what pseudocode looks like. We'll come back and do one last step. Up at the top, we'll kind of make all the data objects that we need. So we'll say object end, and this is going to be what number to count up to. And actually, end is the same as what I was calling end. So we'll do something like that. As an example, we'll say like 20, we want to count up to 20. So we have to say, you know, continue to count until equal to 20 like this. Then I need my object counter, and this is going to be my, you know, 1, 2, 3. So this is going to be my incrementing value. And then the last thing, the easiest thing, I need to be adding up to something. So I just need to make some total object that I can be keeping track of 1 plus 2 plus 3 like this. So we can see this is kind of what it looks like. We didn't use a lot of code, but it kind of looks like code. We have the names of objects. We kind of say it's a while loop without actually putting it in Python syntax. And then we just kind of spell out in plain English the kind of steps of what to do. And then once we have a plan and we think it'll be good to go, now we can come back out and swap all these lines with actual Python code, because obviously this doesn't do anything yet. So now we can begin to fill in the code. And I'm going to do that by just making a space between each line and filling it in. So I still have my notes to look at if I mess up. So we can say like end equals, we want to count up to 20. So we'll say 20. I need to kind of manually count. So I'm going to say begin at 1. I'm going to count, you know, 1, 2, 3. So I got to begin at 1. Total is also easy. Just begin at 0 and then we'll add to it. We'll come back down this way. To begin a while loop, you just say while, and then we need some condition. So what will that condition be? Well, continue to do these steps while my count is less than or equal to end, because I also want to add up 20 itself. So I have to be less than or equal to n. So we'll do it like that. I'm going to add my count to my total. To make this into Python, I kind of have to flip the sentence. Total is going to be plus equal my counter like that. And I need to increment my counter like this. So let's see. And then finally, we didn't actually pseudocode this, but we need to print out what we have at the end. So let's see what we got. We'll do a little quick check and then we'll run back down to explain it again. And let me actually change this. I'll change it to like 3 just so we can easily check it. Yeah, so if I count up 1 plus 2 plus 3, that's going to be equals to 6. So we can check that, you know, it's doing what we should. We can go back up to 20 because that's what we wanted. And we can see it's doing what we want. And let's go ahead and actually copy this, and we'll come back to the Python tool. Oops. And we'll see what this looks like as well as we do it. So say we want to get to 20, so we'll save that as an object. We want to begin counting at 1, so that'll be 1. My total is going to be equal to 0. While count is less than or equal to n, that's still good. So we can go inside the loop. I'm going to add count to my total, so 0 to 1. And then I increment my 1 to 2 like this. Do the same thing. Now I'm going to add 2 to my total. And then my count goes up to 3. Total is going to be equal to 6. I'm going to increment 3 like that. And then we can just see, we keep going. And we can see each step of the code as we go. all the way. Python does every single step as we go. Finally, we get to 20, that's still good to go. And now count is equal to 21. So this is going to be false. So now we'll see this arrow will jump all the way down because we skip all this code and just get to my print statement. And finally, we get total is equal to 210, which just matches up with what's like saved inside Python at the moment that we finish that while loop like that. Any questions or like thoughts about loops as we get into them? We'll keep doing a couple examples of these, but if you don't quite get anything at the moment, go ahead and ask if you want.
Matt, I have a question, not
Yeah.
on the loop, but on the recap you did from the last class, like where you have the string manipulation. My question is, in Python, how do you handle a single apostrophe? String we can use either within single apostrophe, we are writing the string, or double apostrophe, but not together. We don't mix up.
Yeah,
Right.
like that.
You said my first name is Matt and last name is something. My question is, how do you handle single apostrophe or double apostrophe right within the string? Like, do you prefix it with a single apostrophe, or like, for example, last name is O'Brien or O'Hare.
Okay. Yeah, so we could do something like.
Right.
Yeah, so as long as you switch off, if I enclose my string itself in double quotations, I'm allowed to use as many single quotations inside as I want.
Oh.
And the opposite, if I did it like this. Oops, I meant to switch to singles. If I did it like this, I would have to use doubles inside. So the question you were asking is, can I use both inside of a string? Can I have something like...
So right now, what you typed in, that will work, right?
Yeah, this will.
Okay.
But what about something like this? How would we make this into a string? Because we have both double quotes and single quotes. And if I try to like make this into an object, we can see Python sees it as a bug. If I switch to single quotes, it still sees it as a bug. So what we would do is we choose one to go with, and then we use a special backslash key. And this is called escaping. It's basically saying, I'm escaping the thing that follows the backslash. And that means it's not code, it's just text in the string. So I'm telling Python, I'm beginning a string with this. Python knows anything that follows it until the end quotation is that string. But when I get to this point, I'm telling Python, I'm escaping this double quotation. It's not the end of the string, it's actually the text itself. So this backslash is kind of like a little magic thing that says, I'm allowing this as text. Don't think of it as the code itself.
Okay.
Yeah, we'll talk about that a little bit when we get to strings itself in the next two classes.
Oh, okay.
But yeah, it's definitely possible. Yeah, it's obviously definitely possible.
Okay.
It's just, yeah, you have to know a couple things to be able to do it.
Okay. I have another question, which is a very silly question. I
Yeah.
apologize for that. In the email, just now this afternoon or this morning, when you send the email, you have an attachment, right? And
Yeah.
that attachment works with Colab, but when I download, how do you open it? I'm not sure.
Okay, so what you downloaded is it's called, the extension is .ipynb. Oh yeah, it's up at the top.
Right.
So like extensions, it's like, a .doc is a Microsoft, a .xls is a spreadsheet. This means it's a special Python file. And while Colab can accept that file if you upload it, if you just try to open it on your machine not in Colab, you won't be able to unless you have some program that can run Python on the local PC.
Okay. Okay. So the
Yeah.
easiest way to do it, you start Colab, and from that Colab you do file open, right? That
Yeah,
way.
yeah, you have to open it in Colab, yeah.
Okay. Okay. Thank you.
Unless you have some special Python program downloaded, but yeah,
Okay.
we'll keep it all on the web to make this class easy.
Okay. Thank you, Matt.
Oh, yeah, thank you. Okay. Yeah, so that's the while loop. It's not too difficult at this beginning stage. I think I hope you get it. You just do all the steps in the loop, and then you just keep doing it again and again until this condition fails. Pretty easy to understand like that. Next, let's add on a little Python function to be able to do some additional stuff. And this one is called input, and it's a built-in function. Python gives it to us. It knows what to do when we use it. And it's kind of the opposite of the print function in a way. While print takes some message, some input that we put inside the parentheses, it takes that and prints it to the console. Input kind of does the opposite. It accepts some input from the console and lets you save it inside the Python code. In this way, we can kind of input data on the fly, and we don't have to strictly, chisel it in stone in the Python code. We can run a file and change code, based on some input we give at the beginning of the file by just typing it into input instead of saving it in the code itself. So let me show you what this looks like. So what we do is we make we call on input, so we put input open parentheses. Inside of it, we can put some string message, and this is going to print to the console. Let's go ahead and push play. And we can see this sends this message to the console, but then we see we have a box that we can type in. So we can type in anything we want to this console. And we can see this is continuously looping. And what's happening is Python is waiting on us to put in this message to save it in an object called NSG message. And then it'll continue on with the function, with the Python code. So it's kind of paused until we feed it the data that it wants. So I can type in my message, then I can tap the enter key, and then we can see we get to the next and last line, which I print out. What is input giving us? Well, it's giving us a string type. It's just giving us a text. And then we can see I saved what I typed in as an object called message. So this is how we can kind of ask questions in Python. We can kind of prompt who is running the file to input some data on the fly. And then we can even save it in the code. And then when we run the file again, we can type in anything we want, and it'll change the code. Now message has what I just typed in instead of last time. In this way, we don't have to write all Python code by beginning with all the objects kind of like built into the code. And then that would make us come back and kind of edit the code itself instead of just using this convenient input tool. So that's what the input tool looks like.
Matt, sorry for the interruption.
Yeah.
When you finish typing, like at the prompt, when it says, "Do you have a message?" and then you type something, right? This is a message or all jumbo lumbo. Did you hit enter to end it, to stop it, or?
Yep. Yeah. Go ahead and click that. Yeah.
Okay. You did hit enter. Okay.
Yep. Yeah.
Okay. Okay.
Yep, that's how you'll say I'm done typing, and you can take what I've typed up to this point.
Thank you. Thank you.
Yep. So if we want to write some little function, like we'll write a little program to add two things kind of dynamically. We'll put a little print statement in the beginning. And then we can do something like this. We could say A is equal to some input we give. And then we can do it again. And this one will save as something called B. And now we can feed data into this, and then we can print out, something like this if we want. So we can go ahead So we basically made a little calculating program, release a little summing program. It only does addition. So I can say, what is 3 plus 2? And we can see, we have a little bit of a bug. 3 plus 2 is obviously 5. This gave us 32. And this is one of those situations when obviously a bug is happening, but Python has not told us it's a bug. It didn't kind of crash Python. So it seems what we've done is not done something so totally bad that it crashes Python, but we've just used something in a way that we didn't know that we used it. So what we can see is if we take a look up at what we just did, I kind of glossed past it. But when you put something into input, what it gives back, its little output, is always a string type. So if I run this and put in 5, it's still a string. It's not an int. It's not, an actual quantity. It thinks it's kind of text. So what we've done down this way is it kind of treated 3 and 2 as text. And what we don't know yet, but if we have something like this, kind of using the addition symbol between two strings, kind of just glues them back to back like this. So this is why this is 3, 2, it just kind of glued them like that.
So Matt, are you saying input function by default always return a string type?
Yeah, exactly. So it doesn't, even if you type in a 5, it's not going to say, oh, that's a 5. I think I should save it as an int or maybe a float. It just always by default saves it as a string type. Exactly.
Okay.
So if we want to do something like this little calculating program, we might do something like this. I'm just going to do it inside my print statement. So as always, I can just kind of stack things and nest things like this. So I can try this again. 3 plus 2, and now I get 5 because what I've done is I've saved 3 and 2 as a string. But then at the moment I add them, I say, oh, I'm not adding text. I'm actually going to add the quantity 5 and the quantity 2. So that's when I used this int. If I try it again, maybe I could do something like this. And now we can see, oh, now we have an actual bug, something that we couldn't do at all. Let's take a look. It says a lot of stuff that we can mostly skip. But what we might be able to intuit is I gave it a decimal and I tried to make it into an int. So then it couldn't do it because it needed a decimal. So maybe to make this a robust little program, I'll always make them floats. So I can accept decimals if I want. But I can also just accept what is technically an int. And then I can, be pretty robust against bugs like that. So we can see input's pretty useful to make these little programs. We just have to kind of watch out with types, and we might need to cast it into different things.
What happened if I kept B as integer conversion function and A as float conversion function? Could we?
Yeah, that's a good question. So if we did that, we can do this. And that's fine because I gave A as an int and I gave B as a float. So that was able to happen. Okay. But now if I try to give A as a float and B as an int, it fails. Yeah, so that's why I did float on both of them, just so that if someone gives me a decimal point, I can take it.
Right.
Because you can always do math between ints and floats, but you can only accept a quantity if it's a float with decimals. So that's kind of how you have to think when you program. You have to think like about all the edge cases and things that might happen just to kind of solve all bugs ahead of them happening like that. That's a good question, yeah. Okay, so let's put input in the while loop to a little bit of good use and a good example of when you actually use a while loop, which is most useful when you don't know exactly how many times you'll need to use the loop. And that's when maybe asking someone to input some passcode. If they don't get it correctly, we can just say, that was incorrect, try again. So we could do something like this, we can say, so I'm just going to initialize this. Although in a minute, I'm going to say this is equal to some input, what is the password like this. But right now, I'm just going to set it equal to nothing. And you will see why in a second we do that. I'm going to say, while this is equal to nothing, go ahead and do this. So I'm saying begin just a blank object. While this is still blank, this is just an empty string. It just has no text instead of something. While this is blank, keep asking this, input, what is the password, then save it. And then we can do the actual check. We could say if this is equal to, and I'm just gonna type in, what the code would be. Except actually, what we can do is say, if it's not equal to that, make this blank again. And let's see what it does. So you can see as I'm typing in things, what's happening is it's keep asking me, what is it? And then if it's not equal to this, I'm saying make it blank again. So then when I come back up to this while loop, I'm still passing this check and I stay inside the loop until I get it. So we can see once I type in what it actually is, at that point, I don't pass this test, I don't reset it. So this fails in the end. And then I can come outside and say something like that. So if I try it like this, it fails until we get it exactly. And we just use this little bit of logic to kind of reset the loop so we can keep inside until we don't want to be. We can even spice this up a little bit. Maybe as we continue to fail, maybe we want to say a message that says, that was incorrect, please try again. How would we do something like that? Well, we could try maybe something like this. We can say, if wrong, let me just type this out. So we can see we have some object which we haven't made yet, but if wrong, and wrong in this case is going to be a Boolean object. So it's just saying if true, then print this. When would we make that object? Well, we could probably come back down in this place. At this point, when we fail a check, we kind of reset it. And at this point, we might say something like this. We might kind of flick on this switch. So then when we come back up to it at the beginning, we pass this test because it's true. And then we get this little bit. So let's see if this functions now. Oops. Okay, let's see what happened. We have some type of bug. It says we can always just skip down to the bottom because Python is pretty good about explaining what we did. It says we have a name issue and it says name wrong is not defined. If we try to look at what's going on, it's pointing to this line and it's saying wrong is not defined. So what we've done is we've used an object when we haven't initialized it above that line in the code. So even though I'm setting the value down this way, it doesn't exist at this point yet. So Python is getting confused. So let's actually initiate it all the way up at the top. We'll say it's equal to false. so we don't get this in the beginning, but we should get it on the second and any subsequent attempts to type it in. So now if we click play, we get a blank object. This flag is false, so we skip this little bit. We get to the input line. We'll say, there's some stuff. When I click go, I pass this because it's not equal to what it should be. So I make a blank again, and I script this little switch, come back up to the top. Now this passes like it didn't last time, and now I get this. And now if I keep going, I'm always going to get that on subsequent attempts because I always do these same steps, reset my attempt, and just make this equal to true. It'll just keep making it equal to true. That's fine until we get to actually solving it. And then finally we get it accepted and we can leave the code. As you can see, we kind of, it was easy enough to maybe make the beginning of this, the initial lines. But then when we wanted to kind of add some, special functionality to this, we had a couple bugs. We had to kind of put stuff in at the end, come back up to the top, find a bug, come back all the way up to the top. So kind of the sequence of how you make this, how to make the lines of code can be a little wobbly as you define it, which is again why it's sometimes useful to do that pseudocode in the beginning. Kind of spell it out in plain English what you want to do, and then you can come in and just fill in the code. But because we didn't do pseudocode, we kind of messed up the steps a little bit because we tried to think on the fly like that. Okay. Let's get to kind of a big example of code, kind of a big problem. So in this one, we want to simulate, a calculating function. We want to be able to calculate things. And we kind of did that above, but we only did it with addition. We've only added, let's see, when did we do that? We did this, but we can only do addition. We want to be able to do anything, multiply, divide, minus. So we want to be able to calculate. We'll probably be using conditional logic. We might need to typecast if we use input again, because we'll be trying to input quantities. So we'll probably have to cast it to floats and things like that. So I'm going to go ahead and give you guys a couple minutes. You can think about maybe if you don't want to do the code, maybe do the pseudocode, the steps of how you might do it. So we want to be able to do something like, in fact, let me do the initial steps with you to give you an idea of what data you'll be using. And then you can kind of find out how you would finish the problem. So we'll print out a little message. We'll get one input and we'll save it. And then since this is dynamic, we don't always want to add. We want to find out what operation will do. We also need to ask that. So we'll be accepting an input of, what do we want to begin with? And then we'll be asking, what sign do we want to do? What type of math? And then we come back and get the second quantity we want to add. And then we have a bunch of code we still have to do. But if we look at it, we can say, we want to add this. We'll put in a plus sign. And then we want to add that to, something else. How would we go about in these steps doing the addition? How would we detect if we want to add and multiply, divide, things like that? So go ahead and take a couple minutes. If you have questions while you do it, you can ask, but I'll give you guys about 2 minutes to write it yourself, and then we'll come back as a class and I'll do it step by step. Okay, so we'll go ahead and go at this as a class. You might not be done, but hopefully you had an idea of what you wanted to do. So if you want, you can chime in and let me know, exactly what code you did and what ideas you had. And if not, I'll just kind of slowly go down as we go. Okay, so as we saw above when we did that simple addition one, we know input always gives us a string type. So we want to begin with just kind of, we can think of it as like a data cleanup step. So we want to say, we'll do float because that can handle floats and ints. So we want to, make num1 into a float. What can we set that equal to? Well, we can just use the same name again. So I'm going to say make num1 into a float, and then just put it back inside the the object, the box that is called num1. Just kind of swap out its value from string to a float. I can do the same with num2, and with this one, the middle one, I'll probably want to keep it as a string, and we'll see why in a second. Obviously, we couldn't make these, floats anyway. But this last and biggest step, it's just kind of like a series of checks to see what we would do. So we could do something like, we want to check, what is this? So we can just type in the string, plus sign. If the string is equal to a plus sign, well, then we can just do, we'll say like answer equals num1 plus num2. And then I could just keep going down, and I just do it once for each type of operation that I want to allow. Instead of saying, this again, I'm actually going to say else if over elif, because that makes it mutually exclusive from the one above. It can only be one of these, conditions that I'm going to spell out. So I don't need to check each one because it can only be one. So I definitely want to use elif in this case. Just keep going along. Like that. Got one last one. Multiply is just an asterisk. We can say this. And then let's do this. And that looks pretty good. But let's see if it runs, and let's see, even if it does run, it's a totally solid code. We'll take a look. Go ahead and push play. We can see that we had a bug. On line 16, it's highlighted. And when we get used to Python, it might be a little difficult to see what's happening, but it's pointing to what happened. I use the single equal sign, while we need to use the double equal sign to say, is this equal to this? This is the assignment symbol. So I need to do like this. I just made a little typo. Okay, so it accepts the code. That's usually a good sign if it begins to, Let's say, 12, let's do plus, and then we'll do 12, and it comes out pretty good. Let's try it again. Do 12.1 and 12.3. Oops, looks like I messed up, but let's see what happens if we do this. Let's see. So what is happening is it thinks it's something, but what this actually is, let me put this in. And let me try that again. I'm going to do 12, and then I'm actually going to type in, some digits instead of a plus sign, and then I'll do 1. So we can see I'm getting into this else, and I'm skipping all the times that I actually do some math. So why am I still getting a result? Well, that's because this object has been saved from the initial time I ran this cell. In the beginning, my test 1 was 12 plus 12. So it's still saved as that until I went and did it a second time. Because the second time I did it, I didn't update it because I kind of found a bug. It kind of saved and used that old result again. So this is again one different type of bug that we can get. The code runs, we don't get that trace back mumbo jumbo at the bottom. And it prints out everything fine. But what's happening, it's using some hidden data from last time. So that might be something else we need to keep an eye on when we do this. So let's run this again. Let's do 12 divided by 3. And now we can see it updates and does the correct math like that. We'll do one last thing. If we tried to do something like this, we can see we get the bug that we now expect. We can't make SFD into a float, so we get this bug. In this case, it's kind of a good bug. We want the program to kind of fail if someone's using it in the way that we shouldn't. We might see in the end how to kind of gracefully handle these bugs to kind of print a custom message instead of just allowing Python to kind of crash like this. We might be able to see how to do that. But in this case, it's kind of fine because we don't want to be able to do something like this anyway. So this is kind of an okay bug at this point. But we did want to be able to catch this one. If we don't put in a correct math symbol, we put in this else to kind of catch that and let us know that.
Matt, here we did not have to define the word, the variable answer, right? Whether it is a number or float or did we? Did not, right?
Say again?
Answer, the string or the variable answer.
Oh, yeah.
We didn't have to define that, right?
No, so we didn't have to define it because at no point do we use it without defining it. All of these lines actually define it, but we only define it once because we can only go inside one of these at a time.
Right.
So that's why unlike last time when we had to define it up at the top, it's kind of okay that we don't define it up at the top because we only define it when we get to it. If I did something, like this, I would be using it above defining it, so I couldn't do something like that.
Okay.
Yeah. Yep, good question. Okay, so we can see, yeah, not too bad. A lot of things. It's just kind of repeated code. You just have to do condition by condition, a little logic, print at the end, handle kind of the kind of bugs that could come along, but not too bad, this little problem. Okay, so the next thing is the second type of loop. We have been looking at the while loop, the beginning of class. This is the second of only 2 types of loops, so it's not too many to keep track of. This type of loop is a special type of loop that repeats a set amount of times. We saw with the while loop, like with this example, This can kind of repeat as many times as we need it to. It just keeps going and going and going until we pass. That's what defines the while loop. But what defines this loop is it only loops a predetermined amount of times. This is kind of the syntax of how we make it. So unlike the while loop, when we check a condition, which does suggest that we just keep doing it again and again until we fail that condition. This is a set amount of times, and the amount of times is based on, it could be a couple things. One thing is it could be, what this iterable means, is it could be some object that's capable of like being like chunked or like broken down into single elements. So as one example, we could do something like this. I'll explain what everything is when I get to it, when I finish. We can do something like this. And what this is we basically said, and again, a lot of times in Python, we read right to left. So you can think of this as saying, take this string hello, in that, take each letter of it. In this, I just gave this a name. I could call this, anything I want. But it always makes sense to call it something sensible. But I'm going to name kind of each element of what I'm breaking down. And then I'm going to say, loop as many, items that I have. So this is the way of kind of breaking this down into items. So this is one way we can use it. And we can see this is going to be useful when we have like a lot of text data. We can break something down into like lines or something like that to kind of analyze it and do some code on it. We can see, this is the example we saw all the way last class at the beginning of the class. This kind of change in my pockets thing. This is just a second type of object. This is called a list, and we'll see what this is in a second. But it basically is breaking it up elements by element. It's taking each item of it. I'm just calling it coin because that's what it is. So that's what makes sense. I'm going to call it coin. And then I get access to coin inside each loop until I get to the end. And then when I get to the end, it always finishes those set amount of times. If I take out a couple elements, now it's only going to run 2 times because it's preset how many times you run. It's just how many kind of items you have in the thing that you want to break up like that. So let's take a look at what this is. This is a list, and a list in Python is just a type of data object. We've been taking a look at what they call primitive data objects, string, int, float, and the bool type. That's true, false. That's the primitive types. They just each hold kind of like a single value. But a list is of a kind called a sequence, or maybe a collection. And this is a data object that itself contains multiple data objects. So we can think of primitive objects as maybe like boxes, since they have a single value. And we can think of sequences as something that holds lots of boxes itself, like a wagon or something like that. So that's what a list is. And you can imagine that's quite handy. If we have a lot of data, we don't want to manually write a line of code to call each single object. We want to be able to use this thing above to kind of simplify how we get access to each item of the list in this case. What else about lists? The primitive data objects can each hold, one value. Collections can hold multiple instances of data objects, and they can also hold different types at the same time. And they can even have, in this case, a list inside of a list. So it can have a lot of stuff inside of it. It's kind of like infinite in that sense. It can have as many values as you want inside of it. We'll see how to really use lists in a class that's on the way. Right now, we just want to be able to have access to this, basically know how to make them and kind of loop them as we get used to loops, and how to add elements to them. Okay. This is when we add some new, brackets and punctuation to the Python toolkit. Anytime you see these square bracket symbols, that's going to mean that you probably have a list in hand. So when I just say brackets equals my list, what I've made is an empty list in the same way that if I did something like this, I made an empty string. So this is how you make an empty list. If we run this, we see empty list, and it's of the type list. Down this way, sensibly to add values inside of a list when you make it, you just separate them out by commas. So you can see my list is has a bunch of amounts in it. Something else about lists is you can have different types of values inside of them. So we could have something like 1, then we could have like a true value, then we could have some text, then we could have a float like this, and then we might even have like a list inside of a list like this. So you can see just by adding on the list, we can rapidly increase kind of the complexity of the data objects that we have. But again, we won't be doing anything that needs to be this complicated for a while. But the point is, you can put as many things as you want in as many types as you want.
So what is that single with the square bracket, the ending square bracket means there? Yeah, right.
Oh, that was just a typo.
Okay.
Yep. So you can see Colab is kind of highlighting. When you click on this, it's closing the one that opens up this way.
Yeah.
And then this inside list, this like nested list, opens and closes like this.
Okay. Thank you.
So even though this is a list with multiple elements inside of it, this list is a single element of the list as a whole, like this.
Right.
Yeah.
I'm wondering, in previous programming or language, like when we had a list, could we have the combination of different data type? At the beginning, it caught my attention when you said, and now when you were displaying the example, which is true. In my underscore list, you have the list of different kind of things like number, float, text, list, right?
Yeah, exactly. Yeah. Most of the time you'll have, the same type inside of a list. Because that makes sense. You might have like a list of like grade points in a class, or a list of names, something like that. But you totally can have something like this. Okay. If we take a look at this, how do we add an element to a list once we've made it? So we can see, my list began as just an empty string. So when I printed out empty list, and then what is called the .append method, we just kind of tag .append to the end of my object name. And then I can just put a single value inside, 5. And then when I check my list again, it now has a 5 in it. So that's how we can add a element to a list, just like that. Beyond this one method, you can do a lot of stuff with lists. You can like delete elements. You can combine multiple different lists. You can like get a single element out of a list at some given position. But yeah, we'll get to that in the next couple classes, hopefully.
So Matt, excuse me again. Yeah. Can you please go back to your previous example, that my list? Yeah. So where your cursor is, that print my list, is it printing the my list from above, like where you have? Yeah, right. No. Right before that. Yeah, right. Is this the my list here or no?
Yeah. So what's happening is, we can see my list is coming out as this. So it's obviously taking it from this. But if I click play on this, and then I click this, now we can see it change. And what was happening is I had like executed this cell, so kind of saved it inside Python. But even though
Right.
I had this on my page, I hadn't clicked play yet, so I hadn't updated my list. So that's
Oh,
why it wasn't taking this. It began with the empty brackets. As soon as I played
okay.
this, I updated it. If I play this again, I'm going to update it back to an empty list, and then I get back to this like this.
Okay, okay, okay.
When
Got
we
it.
use Colab, we kind of have to juggle, you know,
We
when
need
did I
to.
last update my objects? That's going to
Oh,
be what it is next.
okay. Thank you for showing this. Yeah,
Yep.
I mean, I have to learn Colab a lot, juggle a
Yeah.
lot.
In fact, we can see if we keep clicking play on this, it keeps stacking up fives. And that's
Yeah,
because I keep making my list,
happen.
adding on
Yeah.
a five, and then my list at the beginning of the next time I play it is that list, and then I add on a five. So that's why when I do this little thing, it keeps growing like this. So that's just a little nuance of the, you know, Google Colab, you know, when you updated something.
Okay, thanks.
Lastly, just like we can cast to like instant floats, we can cast to a list if we want, just something to know about. So if I just do something like this, we can see kind of just like my loop broke up a string into like its elements that could be broken up into. When I listify something, it makes it into a list and it takes each individual element and puts it in a list like this. So I took string and then break. And then you kind of break it down as much as you can, and then you get a list with a single elements like that. One last little useful built-in function, we have print, input, type, all the casting functions. One of the main useful ones is something called len. And this is just an abbreviation of length. So basically it just says how many items do I have in a list. So if I say hello is inside the object A, then I get length of A, that's just going to be 5. If I make an empty string, that's going to be 0. If I make a like a list and I put 5 ones into it, this list has 5 elements and 5 items in it. So that's going to be my length of that object. So that's just something else we can kind of stick in the toolkit. We have some way of getting the length of something like that. So now that we know how to use lists, let's get back to the big thing, which is loops. And like we said, we know how to do something. We know how to do something like this, but how would I, if I want to loop something, exactly 100 times, how could I do that without making some value that's 100 long? How would I just say, loop 100 times like this? We can see if I just try to do something like this, that's going to fail. It says, it's basically saying the int objects 100, it's not iterable. And that's because 100 is just one thing. It's 100. It's not 1, 2, 3. So it's not 100 objects. It's just one object, 100. So that's not going to be the way that we can get, 100 loops of something. So how will we do it? We could do something. We could try, something like this.
Introduce a counter and increase that counter, right? Increment the counter.
Yeah, that's what we'll get to in a second. So again, this is kind of the cheating way. We just made something with 5, that's 5 in length. But if it's 100 long, we still can't do that. So yeah, we need some way of counting. We kind of saw that with the while loop. We kind of implemented a manual count. But the useful thing about this type of loop is we don't have to kind of do it manually. We have something called the range function. This is, again, a built-in function like length and type, print and output in input. And the range function basically gives us back, if we put in 10, it's going to give us back kind of 10 items. If I say 10 and I just print something, we can see it repeats 10 times. If I drop this down, to just a couple, it does just that many times, like that. So this is going to be the function we'll look at the rest of today. And this is almost always going to be used in combination with this type of loop. Because while you might do a loop by looping like the items of a list, you might also just want to loop some, X amount of times. And that's when we use the range function. So let's take a look at this in depth. So again, you can combine range with a loop to iterate, some set amount of times. Range basically makes a sequence by counting as high as, what we give it. The input we can call n. So that's the kind of amount of times that we need to loop. So like we saw above, we can't just say for like X in 100, because a 100 is not 100 elements. It's just one element, 100. So we need a kind of like a sequence 100 elements long. So if we take a look at what range is actually doing, let me type this out and we'll take a look at what it's actually making that lets us do this. If we take a look, we'll kind of read right to left. So we can see we did range 10, and we saw above, that's how we can loop 10 times. So we can kind of intuit, it's making some sequence, and we can see it's a list, 10 items long. So I kind of took that, and instead of using it with the loop, I just put that directly inside the list casting function, and I just saved it and printed it out.
Excuse me, Matt.
Yeah.
Is that list, that is a function, not the list data type, right? There is no square bracket, correct?
What, this one? Oh, this. Yeah, this is the list function, yeah, to make the list object. Exactly, yeah.
Yeah, so the function is okay. But when it is outputting that answer, when you click on that arrow, it runs, it is returning you like a list, right? Within square bracket, correct?
Yep. Yeah, so what range is doing is it's making a list. When you say, let me put 10 as input into the range function, its output, which I'm kind of taking in this place, I'm saying swap this out with the actual output of range, make it into a list. We could see what it's giving me back is a list 10 items long. And it's kind of doing exactly what you might think. It looks like it's basically counting 1 to 10 with one slight difference. It's not counting 1 to 10, it's counting 0 to 9.
Right.
And this is something that if you haven't done any type of coding, it's gonna be totally new to you. If you've done some type of coding, you might have seen this. Right. In most coding languages, when you count positions or count elements in a list, things like this, you almost always begin at 0 instead of 1, like we usually do in day-to-day life. And then because we begin at 0 and we want to count up 10 items long, we need to count up to 1 item ahead of the n that we give it. So if we say n is equal to 10, we begin at 0 and then we count up to 9, and then we skip 10 because that would make this 11 items long. So instead of 1 to 10, it's 0 to 9. Why is that? We'll see in the next couple lessons why that is. But just know it's pretty much ubiquitous in Python and most coding languages. So as kind of strange as it might be now, it's just something that you have to get used to until it becomes kind of intuitive like this. So we can see what range is doing. Let me show it again. Oops. Oh, typo. So we can see just what we saw with this example. When I do range 5, it's giving me back 5 items, but instead of 1 to 5, it begins at 0 and stops ahead of 5. So it's still 5 items long.
But see here that 0 to 4, it did not, the output was not within the square bracket, right?
Oh yeah, so what we did, we didn't use it in a loop. this is its own little bit of code. So we took range, and instead of looping the output, we listed the output.
So the list function and the list data type within square bracket are kind of
We'll show you. So if we take a look at this, these two loops do the exact same thing. We can see range 5 begins at 0 and ends like so. And if we take this list, 0 to full like this, it also gives us this when we loop it. So that basically tells us, range 5 is approximately the same. What it's making as its output is something like this. So that's why we can take this in place of this, and it'll come out to the same thing. Because what's happening is when we run Python code, right to left, we do range 5. It gets swapped out with its actual output value, which is this. And then it loops that list one item at a time.
Okay.
Yeah, and it's a little confusing in the beginning, getting used to this. But yeah, just stick with it. It'll make sense eventually. Okay. So that's not all we can do with that. So we could see if we want to add we did this same question with the while loop, but now let's do it with this type of loop and see, last time we had like 10 lines of code. Now that we know how to use this type of loop, if we run this now, it looks like that we did pretty good. We did about half as many lines as it took last time. We can just see if we change this, we have a slight issue. If my question is add up, instead of all the numbers between 1 and 20, add up all them between 1 and 2. So that should equal 3, 1 plus 2. But if I run this, I just get 1. And that's because of what we saw above. We know that range 2 kind of gets changed out on the fly with something like this, because we begin at 0 and then end at 1 ahead of this n. So actually, if I want to add up all the numbers between 1 and 2, to fix that, I would have to do this. Just like that. And if I print this, we can see I'm adding 0 in the beginning, but that doesn't really count. But then I get to add 1, add 2, and then I stop at 2 because I don't want to go all the way to 3, just based on the method of counting that we do. So again, a little confusing in the beginning. You begin at 0 and then you count back by 1. So instead of 3, we get up to 2. But it's just something that we have to get used to. So that's why we'll do a little bit of practice with this. We can see range, it just takes one input as we've seen what we want to count up to. And it basically is kind of like a while loop that we implemented manually. It begins at 0, increments by 1 each time we loop, and ends ahead of n. But what if we want to do like a special type of thing? What if we want to count and add up all the things between 10 and 20? So we know how to do something like this now. If I want to get to 20, I have to go to 21. We can think of this as kind of like a stop sign. We want to stop ahead of the 21, so we actually finish with 20. But what if I only want 10 to 20? How would I do that using range still? Well, we can see range has a second type of way that you can use it. Instead of just defining end, which was the stop, we can also optionally define what we want to begin at. So the default is 0. So this is the same as this. If it's 0, we don't even have to put it in. But if we want to define the beginning, we can just do begin at 10 and end at 20, stop at 21. So this is the second way that we can use the range function to kind of adjust exactly what range, what span of amounts to cycle between. And then lastly, we have one last option that we can add into the range function. We can define what we want to count up to. We can define what we want to begin counting at. And if we leave this out, you just begin at 0. And we can also, following stop, define a step. So instead of incrementing by 1 each time, we can change it to maybe count up by 2s. And we could do something like this. If I want to count up 10 to 50 counting up by 2s, I would say begin at 10. I want to count up to 50, so I want to go and stop at 51. And then my last option is my step, and that's just how much I increment by in between each loop. So I can say, let me jump up by 2 each time. I'm going to print this out so I can see what it looks like. And now we can see I'm going to 10 to 50, and I'm going up by 2 each time. I can make this anything I want. So I can go jump up by 5s. I can jump up by 25s if I want. So there's a lot of options of exactly how many times we want to cycle and exactly what objects we want access to inside that loop. Depending on what type of math we want to do, things like that. Okay. Okay, so we just have the class is done in 5 minutes. So I'm just going to explain what we'll do the last 2 minutes, and then what we'll do next class. So we have some practice problems. We'll do maybe 1 to 2 of them now in class. A lot of these use the range and the loops that we've been doing. So we'll do a couple of these. A little bit of a lesson down this way, but we'll skip that. And then down at the bottom of the page, just like that calculation program we did up at the middle of class, I have some kind of big functions, big blocks of code problems that if you want to do, you can do them in between this class and the next class. Take some time to write out the pseudocode. Take some time to try and do the code, think about how you would implement it using all the tools that we have. And then at the beginning of next class, we'll do some of these at the top to review and give the solutions to them. We have, I think, 3 questions, 3 big questions. And I think I have them in the sequence easiest to difficult. So this one is the easiest, maybe begin with that one. This one is also pretty easy, but this last one at the bottom of the page might be the most difficult. So if you have time, take a stab at it, try and think about how you would do it to really get into the mindset of coding. So we'll do that next class. If you have time, go ahead and do it. And if not, we'll just give out the solutions anyway. But the next 5 minutes, we'll just do a couple of these practice problems to practice these loops again. And let me ask now, while we still have a little bit of time, if anyone has any questions, go ahead and ask now. If you want to go back to anything that we did in the class, we can do that now. We also just go on with some of these to keep going ahead.
Matt, if you could scroll up a little bit slowly, the last but third example, if you can repeat it, not this one. No. Go up, please. Yeah. This one, I think. Add up all the numbers between
Okay. Yeah, let me do it again. I'll do the same example, but let's do it from the beginning. So say I want to add up all the numbers between 1 and 20. So we know we need to keep track of some total that we'll add to as we go along. So we can just begin with that. That's pretty easy. And then we could do a while loop. We did that in the middle of class, in which we would kind of manually count, manually increment the count. But now that we have this range function in this type of loop, we'll use that, since we can see it's a lot less lines of code. So we'll say, number in, we know we'll use range, and let's see how we want to do it.
I'm sorry for interruption, but like here, you are not defining the word number, the string number, the variable number, right?
Yeah, like how did I come up with this?
No, like, is that a fixed like number, what we in real life use the word number for? Is that
no.
how we go, or it is a string, or I can have like XX instead
you can make that anything you want. Let me go back up to the loop, this bit. So this is like the general way to make this type of loop.
Right.
For
Or
X in some type of collection. It could be something like a string. It could be a list of items, but something with a set length. So this is 5 letters long. This is 2 elements in a list. So we need, in this type of loop, some type of object that could be kind of chunked up. This X thing is a name that we totally make up. You can call it anything you want.
Okay. You can just introduce it there, right?
Yep.
Okay.
Yeah, so this, I call it something sensible. In this one, I named it something sensible as well. This is coins of a list of coins, so I just called it coin. So yeah, you can call it anything else you want. It's not something set. You name it totally. Yeah, exactly.
Okay. On the fly, you introduce it there, right?
Yeah.
Okay. Sorry for.
Okay. Yep. No, that's fine. Yeah, so I'm just calling this because I'm adding up, 1 plus 2 plus 3. So that's what I'm getting each loop as I go. I want to add up everything from 0 to 20. So I know if I do this, what this actually is equal to is something
0 to
like
9.
this.
Right.
Because I know we begin at 0 and end ahead of this input. So what I need to do is I need to use those optional ways to make the range function. So I want to say I want to begin at 1. So that'll help a little bit. That'll push me like this. But to get to 20, I need to say stop at 21. So we can think of this as not what we count up to, but what we stop at. So we go 18, 19, 20, stop at 21, and don't do 21. So now I can update this to 20. And then I can just check what I got.
And total equal.
And now we can see I go 1 to 20 because I begin at 1, stop at 21. And I have a default step of 1, so I don't need to put it. And that's how we could count up. And then we just obviously need to actually do the math like this. You can see that adds up to 210. If I want to count up to, 200, I don't know what that is, million, we can see Python can do this pretty fast. It's actually slow because this print statement is slowing it down. So if I take that out, we can see Python can count pretty fast. This is what, 20 million. So yeah, can do that much math in just, a fraction of a second.
Okay. Thank you, Matt.
Yep. Okay. Okay, I'll do one example from this. If you need to go, you can, but I'll just do one example, and then we'll call the end of the class and meet again next time.
Can you
question? Yeah.
Can you do number 3?
Yeah. Print. Okay. Yeah, that's a good one. So let me. So print only the odds between 0 and n. So let's just make an n. We'll say it's just 20 again. I'm going to make my loop. I'm just going to leave it blank and just kind of set up all my code. Because I know what this inside little bit is. I know I just print it out once I get it. But the question is, how do I kind of get 0 to n only odds? So if I have 20, that means I'm going to be, I don't count 0, I count 1, I skip 2, 3, skip the next one, 5, skip 6, go to 7, all the way up to 19, because I'm skipping 20. So now that we have this in mind, we can say, okay, let's think about what range is. It's beginning, stop and step like this.
Mm-hmm.
So what we can do is say, well, we can see I'm jumping up by 2 each time. So even though I'm only counting odds, I still step by 2 each time I go to the next step in the loop. So I'm actually going to begin with my last thing. I'm going to jump up by 2 each time. And then I might say, let me begin at 1.
And then 20, right?
And then, yeah, what's the middle one going to be? Well, yeah, let's put in n, and we'll see what that comes out to. So we can see, yeah, we begin at 1, 3, 5, blah, 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 19. Let's just change this up and check it. So if I go to 21, we can see, while we kind of snuck past it last time, I do realize that I have a bug this time because I want to count n itself. It's kind of inclusive. If n is odd, I want to count it. So we know this is the kind of the stop sign. So I don't get to 21, I get to 20. So I can actually just do a little trick. I can just do some addition inside the range itself. So I'm saying, instead of stopping at 20, let me stop at 22 so that I get to 21. So now if I do this, see, I begin at 1, step up by 2 each time, and then my stop is 21 plus 1 is 22. So that means my last actual item in the list is 21. And that's because this is inclusive.
Yeah.
So that's how we would do kind of like a tricky one like that. Yes, so that's question 3. Question 2, print only the evens. That's probably going to be kind of the same thing as this, with just one slight change. In fact, let's do that. Like in 1 second, and then we'll call the class. So we'll say print only the evens between 0 and n inclusive. We'll say n is equal to the same thing, 21. So I want to get 0 to all the way up to 20 in this case. So I'm actually just going to copy this. If I do this, we can see it's still odds, obviously. But what I need to do is I can just, instead of beginning at 1, because if I begin at 1, then add 2, I always get to an odd. Let me begin at 0, add 2, and then I always get to an even. So I begin at 0, add 2 each time. So 0, 2, 4, 6, 8, blah, blah, blah. And then I get to 20 at the end. And if I change this to an even, just to double check, I still get to 22 itself because I did n plus 1 to kind of change my stop sign in the range function like that.
So Matt, in this collab, like all the examples you just stated in the class, will I be able to? Are you sending us? Can we go back and look at everything you did, or no? That remains with you.
Like will I give out solutions to these?
No. All these examples, like previously, if you scroll up, all the examples, all the code, and while running all the outputs, will you be able to refer it in future before the next class?
Like, do you want me to send you my handout?
Yeah, right.
Oh yeah, if you want, I can, yeah, I have like a final copy of everything totally filled out. So if you want, I can send that so you can check it. But like I said, these questions and these big questions at the end.
Right. Those examples, right.
Oh
What
yeah,
you spend the time on these 2
yeah.
hours.
These
Yeah.
ones, I will include the solutions at the top of the next handout, and we'll do it in class at the top of the class as well.
Okay. Did you send the first classes thing, like in Colab, whatever examples you showed us? I'm sure I'm not clear with my question to you. I'm sorry about that. But
Yeah, I think last handout, most of these questions now come from that handout because we didn't finish all of it. So I don't think we had any questions that we didn't do. But if you want a copy of just like the final notes with all of my notes, I can send that to you if you like. So you have a full note sheet.
yeah, right. If just, just I'm thinking, trying to imagine if something I need to refer to or think like in the class you said something
Yeah.
similar to that, I can go back and refer to.
Yeah, I can send you that, and you have the videos. I'll send out this class video on YouTube as well if you want to take a look at it.
Okay, thank you, Matt.
Okay, yep, thanks. So if you guys have time, go ahead and try a couple of these problems as you can, and then we'll do most of them at the top of next class ahead of going on to the next tools.
Okay, thank you.
Okay, thanks everybody.
Bye.
We'll see you next time.